Alright, so this is the second video for the 2.3 lesson. This one is on the quotient rule. So quotient we know implies division, so we're looking at finding the derivative of f of x over g of x. I'm not going to read all the words here because I think it's more confusing than it needs to be. We're just going to look at the notation here. So whatever's in the numerator, we're going to take the derivative of that, multiply it by g of x, which is the denominator, and subtract f of x times the derivative of g of x and divide by g of x squared. It's important to note that this derivative will exist when g of x is not equal to 0. Alright, so in this example, example 3, we have f of x in the numerator, and we're going to think about what's the derivative of f of x, and we have g of x in the denominator, and we're going to ask ourselves what's the derivative of g of x. Okay, so the derivative of f of x, the numerator, would be 5. That's the derivative of the 5x part. The derivative of 2 is 0, so the derivative there is just 5. The derivative of g of x, well, the derivative of x squared is 2x. The derivative of 1 is 0, so it's just 2x. Okay, so we're ready to find the total derivative. So y prime here is going to be equal to the derivative of f of x, so that's 5, times g of x, so we're going back to this definition up here, and g of x is the denominator, so times x squared minus 1, minus f of x, which is 5x plus 2, times the derivative of g of x, which was 2x, all over g of x squared. So over x squared minus 1 squared. Alright, so now we just have to multiply out and simplify. So 5 times x squared minus 1 is just 5x squared minus 5. And then we are going to subtract, and we're going to do the multiplication of these two. So I'm putting all of this in parentheses. So 5x times 2x is 10x squared. 2 times 2x is plus 4x. Okay. Remember, we want to make sure we're not sloppy about our parentheses. That's why I put that in. Okay. X squared minus 1 squared. You can actually think about multiplying out all the parts. I'm just going to jump to the conclusion. X to the 4th minus 2x squared plus 1. That's one of our binomial patterns. Okay. Moving on, let's simplify this. So we have 5x squared minus 5 minus 10x squared minus 4x all over x to the 4th minus 2x squared plus 1. Alright, we have 5x squared and negative 10x squared. So that's going to give us negative 5x squared minus 4x minus 5 all over 4x squared minus 2x squared plus 1. Needless to say, the derivatives of quotients are not pretty, but that's it. That's y prime. We just found the derivative. All right, I think that we are ready to move on to example 4. Oops. All right, example 4. Looking at example 4, we have in the numerator 3 minus 1 over x. This 1 over x could be rewritten as 3 minus x to the negative 1, but once we take the derivative of that, we're going to have a negative exponent, and using a negative exponent in with the quotient rule is going to get messy really fast. So instead, we're going to change this and manipulate it a little. We are going to multiply by x to both the numerator and the denominator. So just writing out what we already have here. When we multiply by x, that leaves us with 3x minus 1 over x squared plus 5. that's going to work really nicely with the quotient rule. Okay, so that means that my f of x is going to be this part here. So let's find the derivative of that. F prime of x is going to be 3. G of x is down here. G prime of x is going to be 2x. All right, we're ready to plug in the quotient rule. So going back to green again. Actually, let me use blue. Okay, so y prime, the derivative of this y function, is going to be f prime of x, 3 times g of x. And remember, g of x, we're using the x squared plus 5 as g of x. So it's 3 times x squared plus 5, then minus f of x, and f of x is this part. I'm going to need parentheses, 3x minus 1 times the derivative of g of x, so times 2 of x. And all of that is over gx squared. So x squared plus 5 squared. All right. Looks like I'm running out of room here. I'll have to go back and erase some stuff in a minute, but let's just proceed. So I have 3x squared plus 15 minus 3x times 2x, which is 6x squared, minus 1 times 2x, so minus 2x, all over x squared plus 5 squared. When I simplify, all right, I'm going to move this screen up and erase what's above so we can keep working. Okay, so coming back up here and simplifying, y prime is 3x squared plus 15 minus 6x squared plus 4x all over the x squared plus 5 squared. Okay, so I'm going to erase a little more, give ourselves a little more room. Okay, so 3x squared minus 6x leaves us with negative 3x squared, and plus 4x plus 15 over x squared plus 5 squared. And we can leave it like that, or you can actually multiply out the denominator. We're just going to leave it like that. All right, so the next part is not every function that contains a quotient requires the use of the quotient rule. So taking a look at A, the quotient here, your numerator would be x squared plus 3x. That could be f of x, and 6 could be g of x. But it's really easier just to rewrite this with a 1/6 out front, like this. And then we can differentiate with the constant rule and the sum rule. So y prime is 1/6. And then differentiate the inside here, 2x plus 3. So the derivative, combined, 2x plus 3 over 6. And we're done. That's a lot simpler than the quotient rule. All right, let's take a look at the next example. Oh, and this is a 6. There we go. All right, next example, B. All right, when I'm rewriting this, I am going to rewrite below. You can do it in the middle, though. There's a constant here. There's the negative 3 and the 7. So I'm going to put negative 3 over 7. Then we have 3x minus 2x squared over 7x. This sorry, not 7x, just x, we can divide this up so that we're doing, oops, I'll use a different color, 3x divided by x, which would give us, so we have the negative 3 over 7. 3x divided by x here would just leave us with a 3. And then we can do negative 2x squared divided by x, which leaves us with negative 2x. Okay, so now we're ready to differentiate. So y prime equals negative 3 over 7. Then the derivative of 3 is 0. The derivative of negative 2x is just negative 2. So this combines to give us 6 over 7. And that's our derivative. Again, a lot easier than the quotient rule. And that's it.